and today we're going to be doing it's a little cut off here, AMC 10A 2002. Now don't get suspicious, this is not the AMC 10A 2002 answer key, this is the AMC 12A 2007 answer key. Alright, so now let's get to the actual exam, AMC 10A 2002. So let's press the edit.
Can you first tell them some logistics? How many questions there? How many points?
Yes.
How many points if you skip?
Yeah, sure. So for back then, you got 2.5 points for every skipped question and 6 points for every correct question, and there were 25 questions in total. So the max score is 150, and if you left the entire thing blank, you get 63. All right. So, this is basically a joke compared to the AMC 12. So, let's see how fast I can finish it. Okay, 3, 2, 1, begin. Ratio of 10 to the 2000 plus 10 to the 2002 over 10 to the 2001 plus 10 to the 2001 is closest to which of the following numbers? Well, it's about, if we estimate using order of magnitude, 10 to the 2002 over 2 times 10 to the 2001. We don't even need to consider 2000. So, I mean, another way of going about it would be to factor out 10 to the 2000 from both sides. So it would give you 1 plus 100 over 10 to the 2000, 10 plus 10. Well, so the ratio is almost like 101 over 20, which is about 5. So 1 is D. Let's write 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. What? Oh, and 25. Okay, good. Alright, second problem. Given that A, B, and C are non-zero reals, define A, B, C equals A over B plus B over C plus C over A. Find, it's just a computational problem. Okay, that's not that bad. There's not really an approach to solving this. It's just computations. So it's just 1/6 plus 4/3 plus 9 over 2.
Always the problem you're solving should be on the top. Yes.
Okay. So 1 over 6 plus 8 over 6 plus 27 over 6. Which gives me over 6, 36, which is 6. Okay, let's see. Alright. 3. According to the standard convention for exponentiation, 2 to the 2 to the 2 to the 2 is equal to 2 parentheses 2 parentheses 2 to the 2, which is 2 to the 16, which is 65536. The order in which the exponentiations are performed is changed. How many other values are possible? Well, you see, since the numbers are all the same, there are no other possible values, no? Well, let's see. Okay. 2 to the 2 to the 2 to the 2. So if I put parentheses here, you get 2 to the 4 to the 2, which is also 2 to the 16. If I get 2 to the 2 to the 2 to the 2, then we get 4 to the 4. What's 4 to the 4th power? Is it 65536? No, I don't think it is. What's 64 times 64? 6, 1, 25, 24 times 6 is 36, so 38, so 6, 9, 49, 6. Okay, so that's one other possible value. And then I don't think there's really any other way in which it could be changed. I mean, you could do 2 to the 2 to the 2 to the 2. Never mind, I've already tried that. Yeah, there's really no other way to perform it. So there is one other possible value. Well, technically, if you count in the value of, well, no, it says only other values. I will really be salty if it's C. 4. How many positive integers m is there at least one positive integer n such that mn is less than or equal to m plus n? Is there at least one? So for example, what could we use? Well, okay. So that means m times n minus 1 is less than or equal to n. So m is less than or equal to n over n minus 1. So that gets pretty small after a while, I'm not gonna lie. Okay. So the only ones I can think of are when m equals 1, m equals 2. Because when m equals 3, when is 3n less than or equal to 3 plus n? When 2n is less than or equal to 3. Oh, so the restricted diameter actually for n, no? M to the minus n to m. So n times m. So n has to be less than or equal to m over m minus 1. So how many positive integers n is there at least one positive integer n such that happens? So if that was not true, then this must be less than 1. So let's wait. Never mind. What did I mean by that? Because it's always going to be greater than, okay. 5. Each of the small, hey, wait a second, I've seen this. Okay, each of the small circles in the figure has radius 1. The innermost circle is tangent to the 6 circles that surround it. Each of those circles is tangent to the blah, blah, blah. I don't need to hear you. The radius of the large circle is just 1.5 times the radius of the small? No, 2.5 times. Well, no, 3 times. Because you have this, and then you have the diameter of 1 whole 1. So that's 3 for the radius, and that means that the area of the big circle is 9 pi minus the little circles, which are 6 pi, which lead me to D, 3 pi. From a starting number, Cindy was supposed to subtract 3 and then divide by 9, but instead Cindy subtracted by 9 and divided by 3, getting 43. The correct instructions were followed. What would the result be? Well, let's see. N minus 9 must clearly be equal to 43 times 3, which is 129. So n is 138. So if we do 135 over 9, what does that get us? Well, 135 is 45 times 3? Yeah. Over 9. So that's just 15. So it should be A. 7. A 45-degree arc of circle A is equal in length to a 30-degree arc of circle B. What is the ratio of circle A's area and circle B's area? Okay. So that means that 1/8 A is equal to 1/12 B. So, what is A squared over B squared? Okay. So, what's the common factor of 8 and 12? Well, it's got to be 24, right? So, if we multiply everything by 24, we get 3A equals 2B. So, A is 2 over 3B. So 4 over 9B squared over B squared. So it's 4/9. A. 8. Betsy designed a flag using blue triangles, small white squares, and a red center square. Let B be the total area of the blue triangles, W the total area of the white squares, and R the area of the red square. Which of the following is correct? Alright, let's draw this out. So, then we have this section. And let's use highlighter to make most of this actually. We have a section that looks like this, a section that looks like this, a section that looks like this. Actually, no, using it is a bad idea. Okay. So, let's see. We have right on the midpoint this square, then cutting a corner over here, this rectangle, then it creates another square pattern as shown, and then goes back to another rectangle, making another square pattern, which goes back to making another rectangle, and then makes another dang square pattern, and then makes another rectangle, which I didn't have space for. But let's try analyzing this 1/4. Then we can apply that to the rest. So then, can I make any assumptions about the red square? Not really, can I? So then we know this. So we're going to have like a little diagonal. What? Okay, so that means that we're gonna start from here. We're gonna draw a little line like this. So we're starting from here. We're trying to draw a line. Alright. Yeah, this exam humbled me real quick. Is that the right pattern? No, it's not. Man, I am so terrible at drawing freaking patterns. Okay, no need to be a perfectionist. Okay, so we have this, then we have a giant this in the corner, and then over here we have this. Okay, so now let's slather the blue area in. You guessed it, blue. So and then the red area in, well, red, and then the white area in, well, white. Alright, so there's a representation of a quarter of the flag. But honestly, this looks messy. So I'll just write B on every blue part. W on every white part. And R on the red part. Alright, so then what can we say? We can say this is S prime and the whole thing is S. So then the length of this becomes S prime. Oh god, it's too thick, way too thick in fact. So this is S prime. Then this is S prime over root 2. Okay. And this is 2 times that. It does mention they're squares, so this must just be 2 squares stacked up. So just root 2 S prime. So that means the area of this whole segment is S prime squared. No? Yeah. So then one of these white triangles is 1/4 of that, and 2 of them is 1/2 of that. So 3/2 S prime squared is the white area. Then we have the red area, which is just S prime squared. Wait a dang second. 3 blue equals 2 red. That's the one I'm itching towards. So, Alright, so when we have blue, oh yeah, we can say this is just 2S prime, but whatever. When we have blue, this is S prime. So that means one of these fellas is S prime over root 2. And then we're squaring that and halving it. So S squared over 4. And we have 1, 2, 3, 4 of those types. And then we have another one over here. It's just 2 of them stacked up. No? Yeah. Okay. And this one is just S prime squared over 2. And how many of these are there? 4. So that means we have S prime squared plus... Oh, wait a dang second. That means that the blue area is exactly the same as the white area, which means it's A. Nice. That's AAA, but a little...
That's really awesome.
This is problem 8, Dad.
Oh, okay.
Okay, 1001. So we can just say that there were 3 numbers A, B, and C such that 1001C minus 2002A is 4004. 1001B plus 3003A is 5005. What is the average of A, B, and C? Now, the equations have a lot of fluff. Once you divide them by 1000, they show their true colors clearly. And we know B plus 3A is 5. So, first of all, that means A plus B plus C, which is exactly coincidentally what we need, is 9. Then determining the average of them is just B. Alright, 10. What is the sum of all the roots of that? Oh, it shouldn't be hard. That's 2x plus 3 times x minus 4 plus x minus 6. Which is 2x plus 3 times 2x minus 10. So the root here, this root, is equal to, well, 2x plus 3 equals 0, so x is minus 3/2. And this root is x equals 5. So that means adding them together gives us 7 over 2, which should be A. We're on a streak here. Please, Dad, it's distracting me. Jamal wants to save 30 files onto disks, each with 1.44 megabytes of space. Hey, wait a second. 3 of the files take up 0.8 megabytes each. 12 of them take up 0.7 megabytes each, and the rest take up 0.4 megabytes. It is not possible to split a file. What is the smallest number of disks needed to store all 30 files? How many can we pack into a single file? The sad thing, the unfortunate thing, is that we can't bundle up 0.8 and 0.7 because each of them have 1.44 megabytes of space. 3 of the files take up... Why does Jamal have such small disks? He can't just buy a bigger one for $60? Okay. The rest take up 0.4 megabytes each. So, let's see, 12 of the files. Okay, so what I think we could do is pack, you could pack 12.7s and 12.4s into 12 of them. Then, what you could do would be take then you have 3.4s and 3.8s. So you just put them together and you get 3 more, which means you need 15. No? The other approach is packing 3.4 megabyte files and then packing 2.7 megabyte files. So plus 6, and then that gives me 14. So it should be C. 12. Mr. Early Bird leaves home every day at 8 a.m. to go to work. If he drives at an average speed of 40 mph, he will be late by 3 minutes. If he drives at an average speed of 60 miles per hour, he will be early by 3 minutes. How many miles per hour does Mr. Bird need to drive to get to work exactly on time? Alright. You know what they say, the early bird gets the worm. Okay, so let's see. He drives at an average. Alright, so let's say that he needs to cover a distance D to get to work. So, he needs to cover distance D in a time T. Oh my god. I'm really suspecting 50 because the 3-minute and 3-minute intervals are the same. I can't rigorously prove that. So, time, you need to cover that in a certain time T. So, if he drives at an average speed of 40 miles per hour, so if we have D divided by 40, that's equal to T plus 3. But 3 over 60 is T minus 3. How many miles per hour? Okay. So, that means that D over 60 plus 3 equals D over 40. So, D over 60 plus 6 equals D over 40. Which means it's the common factor is 120, I think. What happens when we multiply everything by 120? Well, we get 2D plus 720 equals to 3D. So 720 is equal to D. Well, cease. This this guy has to drive 720 miles to get to work. Alright. So, what time does he need to be there? Well, 720 divided by 60 means 12 hours. Wait, no. It's t minus 3. So that means he's got to get there in 15 hours. Jesus Christ. Okay. He really is an early bird. So, if he needs to drive for 15 hours, it's 3 minutes. So why are we using miles per hour? Oh gosh. Okay. So instead of doing this, I'm gonna have to convert 3 minutes to 1/20th of an hour. So that means that once we combine them, d over 40 is equal to d over 60 plus 1 over 20 plus 1 over 20. So it becomes 1 over 10. 40, 60, 10. All you need to satisfy them is 120 once again. So 3d equals 2d plus 12. So he actually only needs to drive 12 miles to get to work. Thank goodness. Poor early bird. So then that means that 1 over 5 plus 1 over 20 equals t in hours. So he needs to cover 12 miles in, is that 5/20s, which is 1/4. So he needs to cover 12 miles in 1/4 of an hour, which means he needs to drive at 48 mph to get there exactly on time, right? Yup. Okay, so the temptation towards C did not work. The answer should be B. Given a triangle with side lengths 15, 20, and 25, find the triangle's smallest altitude. That should be easy. It's just the altitude opposite to the largest side. Let me flip it over 1 second. 15, 20, 25. We have to find this length because the other altitudes are just the sides. Trust me, I've fallen for that trick once before with a similar problem. So these two have to be similar. So 15 is going to act like the hypotenuse of the new triangle. So we just have to multiply it by 4 over 5. So 12b. Alright. Both roots of the quadratic equation x squared minus 63x plus k equals 0 are prime numbers. The number of possible values of k is... Now, I remember seeing this problem, but I don't remember how to solve it. So, not from scratch. Let's see.
Which one are you skipping?
Huh?
You're skipping?
No. What's 63 squared?
What problem you're solving?
14.
Okay, move it up, please.
9, 18, 37, 9, 6, 9, 39, 69. Minus 4k over 2 is prime. So that means so that means that 63 plus minus this is even. So then, what do we know from that? Well, 63 plus that is even. 63 minus that is even. So 3969 minus 4k. Well, obviously it has to be less than 63, but alright. So if both are prime numbers, then we have to look in like a ridiculous, absolutely ridiculous range. Both roots are prime? Well, then, how would I calculate? This is tricky. So the number of possible values of k is, I'm not sure, honestly. I don't think I can do 14.
Which one is keeping?
14. 15. Using the digits 1, 2. Hey, I've done this one before. 1, 2, 3, 4, 5, 6, 7, and 9 form four
Can you move it up?
2-digit prime numbers, using each digit only once. What is the sum of the 4 prime numbers? So we have 11, 13, 17, 19, 23, 29, 31, 33, 37, 39, 41, 43, 47, 49, 51, 53, 57, 59, 61, 63, 67, 69. Wait, no, 67 is wrong. 71, 73, 77, 79. We can skip the H because we can't use them. 91, 93, 95, 97. I think 97 is fine. Okay, that's it. So we're looking for some of them that use each digit only once. So for example, take 23, then we can't use anything with a 2 or 3. Okay, then we could pick 41, which means we can't use anything with a 1 or a 4. Then we could pick 59, meaning we can't use anything with a 9 or a 5. And finally, we have 2, 3, 4, 1, 5, 9. I think we're missing 6, 7. So that's the only one left. 23 plus 67 plus 41 plus 59. 59. 23 plus 67. That's 80, 90. 41 plus 59 is 100. So it should be 190E. Unless no. Okay. So I think it should be E. 16. Let A plus 1 equals B plus 2 equals C plus 3 equals D plus 4 equals A plus B plus C plus D plus 5. What is A plus B plus C plus D? Well, that means A is equal to B plus 1, B equals C plus 1, C equals D plus 1, and so that means that A is equal to D plus 3, B equals D plus 2, and C is obviously D plus 1. So that means that we have 4D plus 3 plus 2 plus 1, which is 6, is equal to A plus B plus, wait, no. Okay. So this is equal to A plus B plus C. So then we know that, okay, so if we know 4D plus 6 equals A plus B plus C, then 5D plus 6 is A plus B plus C plus D, and 5D plus 11 is A plus B plus C plus D plus 5, which is what we have here. So 5D plus 11 equals D plus 4, So that means 4D, 4D equals minus 7, so D is minus 7 over 4. So that means C is 1 greater than that. And that means B is 1 greater than that. And that means A is 1 greater than that. So 5 plus 1 minus 3 minus 7 over 4. So it should be minus 1, right? Okay, let's redo our arithmetic. So add 4, add 4, add 4, right? That's weird. Alright, let's try doing it with a slightly different approach. So, let's see. So, we know D plus 4 equals A plus B plus C plus D plus 5. Then we know 4 is just A plus B plus C plus 5. And A plus B plus C is 4D plus 6. So 4 equals 4D plus 11. Oh, dang it. This number comes back to haunt me again. Alright. So minus 7 over 4. So now all we have to do is take this and then plug it into 5 and add 6. Hopefully, anyway. That's not good. So where am I going wrong? So 1 equals B plus C plus D plus 5. 2 equals A plus C plus D plus 5. 3 equals A plus B plus C plus 5. And 4 equals, 1 equals B. And 4, A plus B plus C plus 5. So now what happens if we add everything together here? We get 10 equals B plus C plus D plus 5 plus A plus C plus D plus 5 plus A plus B plus D plus 5 plus A plus B plus C plus 5. So 10 is equal to, how many B's are there? 1, 2, 3. 3B plus how many C's are there? 1, 2, 3. And then how many D's are there? 1, 2, 3. How many A's are there? 1, 2, 3. How many 5's are there? 1, 2, 3, 4. Okay. Sure. So 15. Well, no, 20. Alright. So that means that minus 10 over 3 should be the answer. B. Okay, finally. 17. Sarah pours 4 ounces of coffee into a cup that can hold 8 ounces. Then she pours 4 ounces of cream into a second cup that can also hold 8 ounces. She then pours half of the contents of the first cup into the second cup, completely mixes the contents of the second cup, then pours the first cup as cream. Alright, so 4 ounces of coffee. I don't think the holding 8 ounces is relevant. Then she pours 4 ounces of cream. Okay, so she pours half of the contents of the first cup into the second cup. So now this is 2 ounces coffee. And this is 2 ounces coffee, 4 ounces cream. Then C pours half of the contents of the second cup back into the first cup, which gives you 3 ounces of coffee, because 2 over 2 is 1. And 2 and then on the other one, it just gives you almost the exact same thing. 1 ounce over here, 2 ounces cream on top. So that means this is 3 over 5 total ounces coffee and 2 over 5 cream. So it's D. (18) A 3 by 3 by 3 cube is made of 27 normal dice. Each die's opposite side sum to 7. What is the smallest possible sum of all of the values visible on the 6 faces of the large cube? Read that again. Each dice's opposite side sum to 7. Well, that's true of any dice, is it not? What is the smallest possible sum of all of the values visible on the 6 faces of the large cube? Well, it almost looks like a Rubik's Cube of sorts. When we have a 3 by 3 cube, let's actually draw it out. So now, if you have dice over here, let's think about it. These fellas, the ones that are on the middle left, or any of these 4 in general, will have 2 sides visible. Any of these 5 corner fellas will have 3 sides visible. And the one in the middle will only have 1 face visible. So, if we were to draw a map, this would have 3 sides visible, this would have 2 sides visible, and this would only have one side visible. So, what is small? Okay. So, on opposite sides of the cube, then that means you can just have a cube that is oriented like 1, 2, 3, no? Because then the 4 could be on the back, and then the 6 is here, and the 5 is there. Yeah. So it can be oriented that way, and that's what we want. So all of the corner blocks are going to add a value of 6. But the problem is, how many corner blocks are there? Well, each face, there's 1, 2. So in total, oh God, I'm gonna have to count. So there's 1 over here, there's another one over there, there's a third one, there's a fourth one over here, there's let's actually, wait. So we can have a 5th one over here, a 6th one over here, Wait, I just realized because there are 8 corners in a cube, there are going to be 8 corner cubes. Whoops. Now I think the same logic applies for the edges. There are going to be 12 edges in a cube, so there are 12 side cubes. And there are obviously only going to be 6 middle cubes. So the middle die will always be 1 in our plan. One of these fellas will have 1 and 2, and one of these fellas will have 1, 2, and 3. So that means if there are 8 corners, each of those is going to add a value of 6. If there are 12 middles, then they're going to add a value of 3, and you have 6 ones. So you have 48 plus 36 plus 6. Or 48 plus 42, which is a grand total of 90. D. Spot's doghouse has a regular hexagonal base that measures 1 yard on each side. He is tethered to a vertex with a 2-yard rope. What is the area in square yards of the region outside of the doghouse that Spot can reach? There was a similar one I've seen like this, but with a square doghouse instead of a hexagonal one. Okay. Okay. So, he is tethered to the vertex with a 2-yard rope. So what is the area in square yards outside of the doghouse that Spot can reach? Well, it's just gonna be some sort of circle with radius 2 around the base. No? What's this one anyway? 2. Oh. Wait, so correct me if I'm wrong, but, well, no, don't correct me if I'm wrong because this is a test. But this is just the area of the circle minus the area of the hexagon, which is, they're all in terms of pi. Okay, oh, it's because of the same mechanic that's used in the other one. If he goes over this little limit, so he has freedom, all the way up till here. I don't know how exactly I would draw it, but how do I draw this damn thing? So, if he walks all the way over here, it's about twice the side length. So he's mostly a free bird for this 120-degree angle, and it's symmetrical on the other side, so we'll just multiply by 2. But then his rope curls around, so he only has a radius of 1 to free roam over here. So that means that it's cut down immensely from here all the way to that puny thing. Alright, so that means that it's 2 pi, it's 4 pi over 3 plus this little sector, which is, what is it? I think this is 60 degrees, right? Yeah, because this is 120. So 4 pi over 3 plus 1/6 pi multiplied by 2. So 8 pi over 3 plus pi over 3. So it's 9 pi over 3, so it's 3 pi, which is E. A, B, C, D, and E, and F lie in that order on AF, dividing it into 5 segments, each of length 1. Point G is not on line AF. Okay, I have to draw this. What the heck? What's going on out there? So this is A, this is F. The halfway point is going to be C, right? Oh wait, never mind. That's better. Okay. And each of these segments is length 1. Let me erase this random useless point. Okay. Point G is not on line AF. Point H lies on GD and point J lies on G. Oh, Jesus. Okay. So, what are we looking for? This is Z. We know H lies somewhere here. H, C, J, oh God, and J and G, F. Okay, point J lies on G, F. So, we know this, we know this, we know that they're parallel. Kind of don't want to attempt this, but I kind of also have to. Okay, this is tricky. So, what I'm going to do is first draw GDF and factor in C a little later. GDF, this is 2. E is the little midpoint. And we have also C, which is a little bit of an extension, a tidbit. And we know we have a point H lying on GD, such that HC and JE are completely, and AG is also parallel. Okay, so I'm going to have to factor that in. Okay, this is an absolute clit, so I want to keep it family friendly on this channel. Okay, that's not good. Find HC over J. Well, this is a trapezoid, or if you're a British man, trapezium. If they're parallel, that's some good news. You know what? I'm not doing that one. Nope.
Skip?
Yeah.
Which number?
20.
One more skip before 14.
Well, yeah.
Is that right?
What do you mean?
2 skips so far.
Yes. Okay. Mean, median, mode, and range of a collection of 8 integers are all equal to 8. Jesus. The largest integer that can be an element of this collection is... Okay. So let's see. A, B, C, D, E, F, G, H. Okay. So first of all, we know it's the mean. It's the median. D plus E is equal to 16 because D plus E over 2 has to be 8. Alright, second, we know that the sum of all these goofy goobers is 8 times 8, which is 64. So that means that if we subtract 16 from that because of D plus E, you get that the average of these 6 integers is going to be equal to 48. Wait, okay, that's funny. That's very fun. Okay, so the mode is also equal to 8, which is sort of making me think that D and E are both 8. So, and the range of the collection is 8 as well. So 8 minus A is 8. So 8 is just A plus 8. So, in the end, when we try reducing it as much as we can, we end up with this. Okay, so the largest integer that can be an element of this collection is, and this is in order from largest to smallest. So I'll have a few blanks here, B, E, F, G, H, because that's how I've solved problems like this before, which gives you like the mean, median, and stuff. Never got in the range before in one of these. So I know to assume that D and E are equal to 8. Because that's convenient for me, because it allows me to knock out 2 requirements at once of the mode and range. Sly. Mean, okay. Oh yeah, it knocks out the median and mode, not the range. So, well, if it's a unique mode, then we're going to have to go down 7. Jesus Christ. 7, 6, 5. The largest integer in this collection has to be 13. Can we do any better? I'm sure we could. Can we do better? Well, I've got an idea. A, B, C, D, E, F, G, H. We can just make this and this 8. And we can also make this 8. To make this 7 and 7. And to make the range 8, this has to be 15. And then we just have F into G. So we have 14 plus 24 plus 15 plus 2x. We're going to assume that F and G are equal over 8, I think. So it's equal to 29 plus 24, which is 53. I think so. Jesus, they're using the hose outside. So, whew. Oh, this is equal to 8. Oops. I forgot that fact for a little bit. Okay, so the problem is that a little too many things are odd. So that means we're going to have to make this 14. Make this 6 and 6. So 6, 6, 888, like that one full number. And then we have 12 plus 24 plus 14 plus 2x over 8 is equal to, well, technically, you could also say G is 14, but no, that wouldn't help much. Equal to 8. So 24 plus 14 is 38. So that would make them have to be 7 and 7. Ugh, that's not ideal. Okay. Sorry, I was making coal mining sounds. 5 plus 6 plus 7 plus 16 plus 13. Does this work? Let's find out. Okay. 13, 18. 18 plus 13 is 31. 31 plus 16 is 47. 47 plus 2x is okay. So that means that the way it is right now, we can't have one. However, we could fix that problem. Because 47 plus 2x is equal to, what's 64 minus 47? Well, 64 minus 50, which is 14, plus 3, which is, wait, no. 14 plus 3, which is 17. Okay. So it could be 8 and 9. So that's our set. I think the largest one has to be 13. Is there a way to make it 14? Let's try it. 6, 6, 7, 8, 8, 8, 10, 14. Does this work? Let's try. So 12 plus 7 plus 24 plus 24 again over, no, it's equal to 64. Okay. So 12 plus 7 is 16, and it just doesn't work. That means we need to subtract 3 somewhere in the set, which would not work. Unless, no, there's no way to subtract 3 from, 6, 6, 7, 7, 8, 8, oh no, but that would push the each out of their place. I'm going to say the only viable option is 13. Okay, 22. A set of tiles numbered 1 through 100 is modified repeatedly by the following operation. Remove all perfect squares and renumber the remaining tiles consecutively, starting with 1. How many times must... Well, there's only one way to find out, and that's doing it itself. Now, because I'm kind of exhausted, I'm going to exclude the first step, which is eliminating all perfect squares. Well, I'm a little bit more vulnerable to a mistake here. So 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 15. Okay. Oh, I just had a realization. There are 10 perfect squares. So that means that when we renumber them, we're going to have 1 through 90. Then that means there will be 9 perfect squares. So when we renumber them, there will be 81, which means there will still technically be 9 perfect squares. So when we renumber them and subtract, it will be lowered down to 72. Then there are 8 perfect squares, so we lower it down to 64. Then there were still 8 perfect squares. Wait, so, we're supposed to count how many times we do this. So, 1, 2, 3, 4. Then when we subtract 8 again, we get 56. Then there are only 7 left, so we gotta subtract and we get 49. There are still 7 left, so we have to subtract and get 42. Then there are 6 left, so we have to get 36. And then there are 6 left, so we have to get 30, at which point there are 5 left, so we go to 25. There are still 5 left, so we go to 20. There were 4 left, so we go to 16. There were still 4 left, so we go to 12. Now there were 3 left, so we go to 9. There were still 3 left, so we go to 6. There were 2 left, so we go to 4. There were still 2 left, so we go to 2. Now there's 1 left, so we subtract 1. Okay, how many times did we do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Oh, god dang it, it's a trap. C, D, and E are all the same. Okay. I'm gonna say it's C. 23. A, B, C, and D lie on a line in that order. Not in that order again. With A, B equals C, D, and B, C equals 12. Point E is not on the line, and B equals C. I'll try. Okay. So, A and B, we have C and D. These are both, let's say, a length of x, and BC is exactly 12. Point E is not on the line, but BC is equal to CE, so they form the sort of isosceles triangle, is equal to 10. 10, 10. Okay. The perimeter of AED is twice the perimeter of BEC. Alright, BEC obviously right off the bat has a perimeter of 32. So AED has a perimeter of 64. Alright, so now what can we do? Well, we have 6 and 8. Seeing an opportunity and I'm trying to pounce on it. So we have 6 and 8. Now what would happen if we had 6 plus x plus 8? So then, when we square both of them, put them under that square root, we get x squared plus 12x plus 36 plus 64. So it's root x squared plus 12x plus 100. So the crucial thing is finding x. Then we multiply that by 2. Well, the thing is, finding x is literally the entire problem. And then we add that to this total thing, which is 12 plus 2x. And this is supposed to be equal to 64. Dear God. Okay. So I'm going to try simplifying it as much as I possibly can before I have to face the harrowing truth. 64 minus 12 is equal to 52, if I remember correctly. So we have x squared plus 12x plus 100 plus x is equal to 26. Alright, we're getting somewhere. So x squared plus 12x plus 100 is equal to, what's x minus 26? X squared minus 52x plus 676. Yeah. So, and this should lead us to the answer. So 64x is equal to 576, which is just 24 squared. So if we divide by 8 on both sides, we get 8x. Well, if we divide by 8 squared on both sides, we get x equals 9, which is D.
My God.
24.
My God.
One problem from the end. Tina randomly selects 2 distinct numbers from the set 1, 2, 3, 4, 5. And Sergio randomly selects a number from the set 1, 2, all the way to 10. What is the probability that Sergio's number is larger than the sum of the 2 numbers chosen by Tina? Alright, let's think about this.
Isaac.
No, I don't need to think. So, how do we... It's a lot of casework, I think. I'm not going to put myself through that torture. So, this is going to be my third question that I skip.
Okay, what is the number?
24. One question from the end. And this is the last question. Literally at the end of the page. 25. Trapezoid ABCD has bases A, B, and C.
Just tell the audience that you never ever try the last problem.
Well, that's on the AMC 12. But this is the AMC 10. So this joke is kind of like AMC 12 problem 16 or so. Which is tricky, definitely. But it's not as stuck up as you would expect it to be. In trapezoid ABCD with bases AB and CD, we have AB equals 52, BC equals 12, CD equals 39, and DA is 5. The area of ABCD is... Alright, let's try. $52, $12. It kind of looks parallel. So we'll give that a try. What else do we know? Not much, to be for sure. Okay, put your thinking cap on. Oh, I have an idea. We do know that if we call this A and this B, A plus B has to be equal to 13 because that's the difference between 52 and 39. What else do we know? Well, we also do know that this is going to be the exact same. C and C. So, square root of A squared plus C squared is equal to 5. Well, A squared plus C squared is 5. And B squared plus C squared is equal to 12. So, well, no, 25 and 144. So A squared plus 2C squared plus B squared is equal to 169. Oh, I just realized. That means A squared plus 2C squared plus B squared is equal to, since A plus B is 13, A squared plus 2AB plus B squared. So C squared is literally AB. That's some good news, I guess. So this is AB. AB. Okay. So Alright. What's the area of both of these? Well, one of them is going to be... Oh! I just realized. That means we also know this is A squared plus A squared B squared. Which means it's A squared times B squared plus 1. Or A root B squared plus 1. And I think a similar logic happens here, where it's B root A squared plus 1. So A root B squared plus 1 is equal to 5. B root A squared plus 1 is equal to 12. Now there is a plentiful of things I could do here. A squared times B squared plus 1 equals 5. A squared is 5 over B squared plus 1. Now my temptation is to plug it in here, but I'm not Wolfram Alpha. So I don't think I could solve that. Nevertheless, let's try it. It's equal to 12. Then obviously the only way we're getting out of here alive is B squared times B squared plus 6 over B squared plus 1. And this is equal to 12. So, you know, B squared times, okay. This is a fascinating problem. 1 plus 5 B b squared plus 1 is 12. So, 1 second, b squared plus 5b squared over b squared plus 1 is 12. So b squared plus 5 minus 5 over plus 1 equals 12. So b squared minus 5 over b squared plus 1 is equal to 7. Once again, I'm not Wolfram Alpha, so I'm not sure if I can do this. It might involve Simon's favorite factoring trick. A plus B plus AB plus 1, perhaps? Equal to... Well, I'm not sure. So, this is my fourth, and obviously it's gotta be my final skip.
25?
Yup.
5 is skip. Alright, we are ready to...
4 skips.
Yeah, 4 skip.
Oh man.
Use it. Can you... Okay, use it.
Let's see how well I did. Answer key. Cross fingers, everyone.
Cross fingers.
D, C, B, E, C. Oh, whoops. Okay. So, A, B, A. Oh no, B. Skip. What was B? D. 21. Oh no. D, C, D. Alright, and skip. And 24 was A and 25 was C, by the way.
Alright, okay.
So let's count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right?
18 times 6.
Plus, oh, by the way, just wanted to let you know there's...
Cut off, okay. So
Wait, no, 1 second.
Okay.
There's a little bit of a quirk that since this is the 2002 AMC, you get 2.5 points for every question.
Not 3?
No, for every skipped question.
Oh, I see.
So you get extra points.
Oh, okay.
So 1, 2, 3, 4, 5, 6, 7, 8. Wait, no. 1, 2, 3. Wait, no. 1 skip, 2 skip, 3 skip, 4 skip. Okay, that took me a little while to figure out. So 10 plus
Ref! Hey, remove! So is this your highest score?
Well, this is the AMC 10A, so it's not very relevant to the 12A. So if this was the 12A, it would be approximately maybe 90 or so.
Oh, I see. Okay.
So maybe it's my high score for the 10A, but that's not the exam that I'll be taking.
You're gonna be taking 12A.
Which is much harder,
But
actually.
yeah. Okay. All right. So you wanna make a final statement before you leave? What would be your strategy? What is the maximum score you can get?
150.
In AMC 10A?
Yes, 150.
150, and you got 118. So because you skip how many?
4.
And you got how many wrong?
2.
Can you tell me the problem that you got wrong?
3.
Tell
I
me.
got 5, 11, and 21 wrong.
21 wrong. So basically 1, 2, 3, 4, 5, 6, 7. 7 problem you had a. Yeah, I mean, 7 challenging problem you had, right?
AMC.
All right, now we have to go.
1 second. I want to see this thing.
Oh, you want to see the cutoff?
Yeah.
Yeah, me too.
It's dumb smartboard is pretty broken. I didn't mean it smartboard. I'm sorry. Did I offend your feelings?
No.
All the way back. Oh.
Okay, I want to see the cutoff.
2002 AMC 10A. 115.
115 is the cutoff,
Yeah.
and you got 118.
Yeah.
So
Very
you
close.
barely made it.
Yeah.
Not that impressive, right?
Well, yeah.
Yeah.
The thing is, the cutoff is much higher than the AMC 12 because, I mean, the AMC 10 and the AMC 12 people are going to the same exam, but the AMC 10 are taking an easier exam than the AMC 12 people.
So the cutoff is of
Higher,
course higher.
yeah. So, for example, the cutoffs here are about 120, while the cutoffs for the corresponding AMC 12s are exactly 100. And they have the corresponding passing rates. You have AMC 10 about 1% pass, and the AMC 12 about 7% pass and 17% here.
I see.
Alright, thank you everybody for watching, and we'll see you in the next one. Goodbye.